Hello, everyone. Thank you for being here, and hopefully you're having the great first day of the Spark AI Summit. And I'm sure you guys had like a very long day. This is probably the last session, and then you'll head off to the party. So we'll start the party a little early, so you're not going to be hearing an overload of information from me. What we're going to do more is today we're going to do a whiteboarding session. So we're going to divide into groups. You're actually going to get to know some of your peers, and we're going to come up with a system design, an end-to-end data pipeline design for a given customer scenario, and I'll explain what that scenario is more. So before we jump in, I know the session was titled Advanced Analytics with Cosmos DB, but is there in the room someone who doesn't know what Cosmos DB is? Everybody knows what Cosmos DB is? Awesome, awesome, that's great. So my assumption would be that most people in the room have at least a little bit knowledge of what Cosmos DB is and the different Azure services, because that's what our discussions will be centered around. But if not, through the lab, if you have any questions, feel free to talk to me or ask me any questions. And I'll give you like a gist of the different services you want to think around. And if you did not use that service, or you have like any questions about why I would use that service, feel free to ask me, but also feel free to pull up Google and do a little bit of reading if you're unsure about any one of those services. So with that, let's start. So a quick introduction. So I'm Shri. I'm a product manager on the Azure Cosmos DB team. And mostly I'm working on unifying this gap between OLTP and OLAP. So like you know, Cosmos DB is a NoSQL database. And a big problem with any NoSQL database is the way they're structured. They can handle massive scales of data, and they're awesome for transactional processing. But when it comes to even simple aggregate queries, they tend to be super expensive. So for a real-time data system, how do you bridge this gap between analytics and transactional workloads? So this is something me as a PM on the Cosmos DB has been working on. So the answer for this right now is we have a very awesome Spark connector, which you can use to connect to Databricks and then pull out some of your data and do the analytics in Databricks. So with that, let's see what we're going to be working on today. So I'm going to skip this slide if everybody knows what Cosmos DB is. So I just put this in there just to see if there are any newbies to Cosmos DB itself. I wanted to do a brief intro. Do you guys want a brief intro, or are you good? Everybody knows Cosmos DB here. Experts? Okay, then I'm passing out a test. Okay, kidding. Okay, great. So today's scenario, what will we be working on? So today we have this customer called the Woodgrove Bank. And what Woodgrove Bank actually does is it provides transaction processing systems to their merchant customers. So let's say you're a merchant, you're selling some services and stuff online. Woodgrove Bank helps you process those payments from your customers. So these merchant customers they're worldwide. They have customers around the world. So what they want to do is they want to build a real-time fraud detection system. And what this fraud detection system should do is as a transaction comes in, you want to flag it as fraudulent. If it is fraudulent, you want to block the transaction. If not, you allow the transaction to go through, and you also want to do some offline analysis to see to sort of come up with the suspicious transaction and give it back to the merchant so they can do further analysis or sort of stop the order. So to do this, they want to do several things. They have several requirements, and before that, what do you want to take away from this session? What should you learn? So you want to learn how can we leverage Cosmos DB's strengths. So for example, Cosmos DB's biggest strengths is its global distribution. So how can you leverage some of Cosmos DB's strengths along with other services like machine learning, real-time processing, and big data to build a globally scalable, low latency, and high throughput solution? So what I want you guys to do is, if you have a laptop, I want you to go here. So this has the participant guide with all the instructions for the workshop. If you don't have a laptop, that's fine. I will display the instructions later. But this is where the entire guidelines for the workshop are, which we will be following. So if you have a laptop in handy, go here. I'll just give everyone a minute. So what we're going to do today is the first 10 minutes, I'm going to explain the scenario. I gave a brief just that we will be building a real-time fraud detection solution. So we will go a bit deeper and understand the customer needs. What does this, our fictional bank, Woodgrove Bank, expect from this solution? So once we have these needs of the customer, we will divide up into groups. So we will make groups of 4 to 5 people. That's why I asked people to sit together. And I will give you 30 minutes to come up with a system architecture diagram. So you will be discussing with people next to you. You will weigh in the pros and cons. And just to get you started, I will give you examples of the different services that can fit into the different stages of the pipeline. And you will spend 30 minutes coming up with this architecture design. And then what we'll do, that the fun part is you will challenge your other groups. You sort of will ask, okay, why Cosmos DB? Why not event hubs? Those are the discussions we actually want to have today here and sort of get more details. And after that, I do have an ideal proposed solution, which I will share with you and why we chose that solution. But by no means it's the only solution. It's like, you know, with system design, there are several different options, and it totally depends on the trade-offs between your business needs and the costs and several factors. But we will also discuss the final solution in the last 10 to 15 minutes. Okay, so if everybody is on the page I provided, you can either look at that and read through the customer scenario. I will also give a brief intro of the scenario we'll be working on. So like I said, Woodgrove Bank, they want to apply machine learning and advanced analytics, and they want to detect fraudulent transactions. So also, they're globally distributed. That means they want their solution, whatever this fraud detection solution, to be as close as possible to their customers so that they don't see that delay. You know that delay when we put in our credit card details and press purchase, it takes a lot of time. They don't want it to be super long, so that means your solution will need to be globally distributed and be close to your customers. And there are two main requirements for this solution. First thing, they do want to prevent fraud in real time. So that means as a transaction comes in, if you're very confident that it's a fraudulent transaction, we want to block it and the transaction will not go in. But they also don't want to be too aggressive. They don't want false positives like, hey, the transaction, for example, I was traveling to Europe, I'm trying to make a purchase, but my bank blocks it because it's from an unknown location, but it was not fraudulent. That frustrates the merchants and the customers. So unless you're confident with a very high degree that the transaction is fraudulent, you do not want to block it. You will let it go through and you will do some more in-depth analysis. You will run batch processes and sort of do more analysis, and then you will flag these customers as suspicious to the merchant to take further action. So you will need sort of two types of solutions here. You will want to block this in real time, but also you want to score some of these transactions offline in a batch format. So Woodgrove Bank's customers are end merchants. They're all around the world. Like I said, the right solution should minimize any latencies experienced by using this service. So to train the models itself, so if anybody has worked on training models, you need some good classified data. So the customer does have this data, and we can assume that they have historical transactions flagged as fraudulent or not in the form in a tabular format in CSVs, which we can export and use to train our models. The other also, they're also very interested in the notebook-driven approach. So I'm sure you guys are at the Databricks conference, so you know what notebooks are. So the notebooks are the sort of the most interesting way for data scientists to explore data and do different sorts of analysis. So they are interested in a notebook approach. So our solution has to provide that. And they also have another requirement is they have different sorts of people, like they have analysts and they also have developers who will be looking at this data. So apart from notebooks, your solution should also be able to integrate with Power BI and other reporting services. Okay, so to summarize the scenario, what will we be building for? So we will be building to detect fraud for merchant customers and sort of give them, block them in real time and give them an early warning. And we also, we want to store data from streaming sources. So the first step, so you have your customers making purchases, let it be their on mobile devices, on laptops, wherever. So you have millions of transactions coming in. So how would you stream these events from these different sources, and what would you do next? So that's something you want to think about. And the second thing is about long-term storage. The customer also wants to store these transactions in long-term storage to retrain their models and for historical purposes. So let's go back to your lab. So I kind of gave a brief gist of the customer needs, which is sort of step one. If you were not clear, or if you want more context, you can spend 5 minutes reading that, and then we will start off with actually designing the system. So here you have the customer situation in step one. So this is kind of, I summarized it for you in the basic gist, but if you want more details, I'll give you 5 minutes. Don't spend too much time, just skim through it. And then if anything else, you want to read the customer needs and objections, because that's what you want to keep in mind as you design the solution. Yes? Um, I have a few pens, but let me check. Ooh, I like it. I already see people jumping into the solution. That's awesome. So if you're sitting in groups of four, if it's more convenient, would you want to discuss this way, or would you want to like turn your chairs back and face each other, whichever works? Yes, four versus four. So four of you can work together, or if you prefer, it'll be easier, you can turn your chairs. Yeah. No, no, how about you turn that way and discuss with them and this way? Yeah, yeah. So folks, if you already read the requirements and I see people are discussing, that's awesome. It's okay, groups of 4 or 5 or whatever. I like how they found a group. So join any group, face each other, make yourself comfortable so you can discuss, and then we can get started. So to give you a quick idea, so here's the common scenario. So for every stage of the architecture, there's several options. So just to get you thinking, it doesn't have to be Cosmos DB or Events Hub or Kafka or whatever, but this is just to give you more of the idea of what are the different services available to help you through each of these different stages in a data pipeline. So how would you ingest this data? How would you process the data? And then how would you analyze and finally serve your data? So these are the different steps which are common to any architecture, not just the fraud detection. And I know most of you worked with a few or some of these services, but if not, just to give you a start, these are the things I want you to think around. If you're unfamiliar with any of them, you can ask me or feel free to Google. This is not a test. Yeah, that's one thing. And the second thing, sort of, we will give you 20 to 25 minutes to work with your teams to come up with a solution. And then we will discuss it with another group and also see the final solution. But before that, just to sort of give you the idea, these are the gaps you want to sort of fill. So you have these transactions coming in. What would your data ingest be? How would you process this data? What service would you use to do the model training? Where would you deploy your trained model? For the suspicious pre-scored activities, how would you store that so the merchant, so your merchant customers can access your suspicious transactions? And then finally, there's the long-term storage and the analytics serving. So these are the different blanks you want to fill, or your architecture design should sort of be structured around. So just to give you an idea, it does not have to follow that format, but usually it's nice to have some sort of framework in mind to help guide your thinking.
Hello, everyone. It's great to see that you're so engrossed. We are technically meant to have a break now and then technically meant to start another session. I'm not going to kick you out because it looks like you're all having some really valuable conversations. But Natalie here, for our data purposes, I'm sure you can appreciate some good data. Would just like to scan everyone's badges as well. But by all means, if you want to have a comfort break now, then go for it. So thank you very much.
So, like the session is split over two sessions, so it looks like they will have to rescan you just for the data purposes for the next session. Yeah, so she'll just come around. Feel free. Technically, there was a 10-minute break, but if you want to leave the room and come back, that's fine. Otherwise, we can keep going. So just a quick check-in. How is everyone doing? Like, if are people good to wrap up in 5 minutes and then ready to talk to other groups? Okay, awesome. Anybody else who needs more than 5 minutes? Just let me know. That's fine. You guys need more than 5 minutes? Okay, okay. I know these are tricky questions and you're debating each other, but try to wrap it up in 5 minutes. It doesn't have to be a perfect solution, and then we'll see what other groups came up with. Hey, folks, um, please stop. I'm sure you guys all did a great job, and you're still putting those last touches. But let's stop for a minute. What I want you to do is to actually your group is gonna discuss the solution with another group, and what I want you to do right here is more of question their assumptions. They said, okay, we want to use Kafka. Okay, why Kafka, and what did you use? And this is what will get you sort of to the meat of it, like versus why your group thought something was good versus what the other group came up with. So please talk to the other group. I will give present your solution. One person from each group a volunteer. So who's going to present here? Who's going to talk about your solution to the other group? Not, you don't have to do it to me. Okay, so pick somebody, and I will give you 5 minutes. So I need one hand up from each group so that I know who it is. One hand up, please. Okay, one hand, awesome. One hand from that group. Okay, one from there. You? Okay, from here, one. Okay, perfect. So can we come here, or since can we just go there so that you can talk to the other group? Awesome. Okay, so I just want you to talk to the other group, the closest to you, and sort of one person who volunteered present the solution. Okay? Yeah. Okay, cool. How about this team? So who's talking from this group? Okay, go, start. You have 5 minutes to tell them why your solution rocks. And the whole group. You can. So be very challenging, guys. You cannot let the. So you want to convince the other group that your solution is the winner here. Tell us why your solution rocks. Tell them you have 5 minutes, and then they will question you based on your. Okay, cool.
So mainly our solution rocks because we rely solely on
Awesome. So here we have two different groups. Cool. So who's going first? Awesome. Tell them why your solution rocks. Like, why is the solution?
The winner gets what?
because
The winner gets what?
The winner will get some goodies.
we have no Azure services.
Can I read from the event?
Oh, so you are or Spark ML or whatever.
Okay. Spark came out, and that can bridge to Azure machine learning, or you could use TensorFlow, or you could use KVS. Alternatively, if it's free,
You can join, come in, but this was like a two-part session. So the first 40 minutes, they worked on the solution, and now they're kind of debating the solutions. But if you do want to check it out, it's all online. So if you Google MCW Real-Time Advanced Analytics with Cosmos, you can just Google it. You will have a GitHub repo with the full solution.
that's brilliant. Thank you.
Thank you. I just want to be mindful that
What's the name of the URL?
MCW Real-Time Advanced Analytics with Cosmos. So the first GitHub link, oh, come on.
one person that just get out. He was coming from here. He's a friend of me. You know in which group he is? I can join the group, and when he come back, I can. No, you don't. You don't. So.
Or they can do every 5 minutes they get all the transactions.
Folks, just a quick check-in. Don't go into too many details. Like, just pretend that you're presenting to a business stakeholder. You will say, okay, this is what we want to do. Just don't go too much detail. I've heard, I was going in and people are getting into very tiny nitty-gritty details. So just present your overall solution and then let the other group ask questions because you only have 5 minutes to present your solution. So don't go into too much detail.
We have another workshop.
Okay, no worries.
What's the your solution?
You can look it up online. I'm not going to force it.
On the link? Okay, thank you very much.
So we have something similar. Well, ours is quite simple, so we just done topics in Kafka. There is the
So basically, can we use a Cosmos DB for basically take a slice and dice within the Power BI?
So there is a yeah, so you can hook it into
But is it a good?
you will extract it and then you will do the slice and dicing in the Power BI extract.
So it's not good for me now.
I know they're working with it. I can follow up, but it's not 100% sure.
So if you want to do something like a slice and dice, then this database data will be a good choice. So
Delta could be a good choice for you guys. You're asking all the right questions for the solution. Probably the Databricks, you have to keep the cluster running, right? So instead of that, you may probably use Azure Analytical Services.
okay, like some proof or maybe like some simple database.
Exactly, yes. That's
Because they were not given in the solution,
yes.
so we will.
No, No, but yes, those were.
Maybe we can show our solution.
Yeah, sure.
Go over that. So what this is
Usually these has more steps. Because with these are usually the drones are master stable, so they check only they don't
So we just everything here is a raw. So we don't treat anything. If it's overall, we just serialize the rest of this. Then we split by event. For example, if we have customers account transaction, we have three deltas: silver customer account transaction. If you have another metadata from other systems,
But yeah, good job. Do you guys like some data stickers?
thanks a lot. Thanks a lot.
yeah, of course. Depends of the model.
Yeah, of course. For example,
Mostly it's not possible for the large model to analyze and we basically they can use more methods.
Yes, I'm with Microsoft, yes, but not based out of Red Waters.
Yeah, I think so. That really depends on your use case. Yeah.
Joystick, yes, I know.
After ACM,
First of all, like in presentations, the service doesn't see, for example, and then after actually understanding what our service is, maybe with some actually with some workshop, it can be a very nice use case actually to work on. Which is good.
We didn't have a story, but the whole solution, we kind of we provide a lot, and we're actually building a real use case.
We can build.
Yes. So I will give you the solution, and you can go home and deploy all the resources and do it. Yes, in Azure. So unfortunately, today we don't have enough time. Otherwise, I kind of provide resources for all our participants so that they can do it all here. But you have to use your own subscription. But yes, the solution will tell you how to do it.
that's the amount of
Folks, just a quick check-in. I'll give you 2 more minutes. Any final thoughts, any final questions? At this point, you should be done presenting your solution and the other group should be asking questions. But if they ask questions while presenting, that's fine too. So a final few minutes before it's the other group's turn. Okay, folks, that's good. Give your other group a chance to present as well. Please swap the roles. The other group, go ahead and talk about your solution and why you think it's awesome. And then the other group will actually challenge it. So if they give you a hard time, this is your chance to give the other team a hard time. Swap, guys. Oh, you done both? Okay. Everyone's done with both? Oh, that's fast. Does any other group need more time, or did everyone get a chance? Okay, I'm going to give a last few minutes since most people did both groups. I'm going to give another 5 minutes and then we'll look at the solution. Okay, folks, let's go ahead and see the solution now. I think everybody had great discussions. Thank you so much. All of you guys were super engaged. I hope you made some friends to go hang out with at the after party. And you can continue debating over drinks too. You can be like, no, your solution sucks, but good. I'm glad all of you were really engaged. So let's start. Okay, for the first data ingest part, so let's pick one team. That team there was having very heated discussions. I'm very curious, what did you guys pick for the data ingest part? How were you going to handle the streaming events?
Oh, hang on a minute for the recording.
So we were going to use Kafka Stream. And then that would be used for storing into the data lake, but also for our implementation of the model as well.
Okay, cool. Could you just share with me in the room why Kafka?
So we could use Event Hubs as well, but I think from experience, Event Hubs only handles 60,000 messages a second, whereas Kafka can go up to 1 million. So we're thinking with banking transactions, maybe you need 1 million per second.
Interesting, but Event Hubs also can handle millions of transactions per second, so that statement is not necessarily true. But Kafka, no, that's fine. Just for the awareness of the room. But yes, Kafka could be a potential solution. But anybody else who used either Event Hubs or Cosmos DB want to tell why it could be better than Kafka here? Anyone? Anyone? Yeah, awesome.
Oh, hang on, sorry.
Yeah, just we use the event hubs to ingest it, but we put not just event hub, but with an API management in front.
Okay.
To be able to also control from which merchants we want to accept transactions. So we give them merchant by merchant and a subscription key, and so we
awesome.
So that's what.
Interesting, super interesting. Yeah. Yes, we have.
So for our team, we took another approach. Actually, for a resilience reason, we decided to use service bus as a queuing service, and the only trigger supported by service bus is event hub. So once we receive data in event hub, we can store it in queue it in service bus, and later, if we don't have an acknowledgement, we won't lose our data. It will be stored in the service bus.
Got it. Okay, great. Awesome suggestions by everyone. So for the data processing part, was there anyone else who picked something other than Databricks? I would be interested to hear. Okay, everybody picked Databricks. That's great.
Good, you can all stay for the party.
Yeah, but well, I'm surprised you guys missed Cosmos DB, but that's fine. But yeah, so the two options which we thought were ideal while we built the solution was either using Event Hubs or Cosmos DB. And the main reasons, both of them are really good options because they can handle millions of transactions at scale. And one thing you want to think about, or why a Cosmos DB could be an interesting choice here, is about the global distribution aspect. So you do have customers all around the world. So if you want to replicate this instance, it would be much easier to do it in Cosmos DB, one thing. The second thing is also we didn't get to that part, but if they were to store their data further in Cosmos DB, say if they're going to store their pre-scored data, you will not need to manage 2 more services. That could be a second reason. We have a question. Yeah.
Excuse me. My question is, okay, you're getting the data in, but you need to respond. You need to respond to the vendor. How do you do this?
Awesome. The question is, you get the data in, but the response to the vendor. So how many of you guys know of Cosmos DB change feed? Okay, not a lot of people. That's why you guys didn't pick Cosmos DB. Okay, so the reason why we even put Cosmos DB in the ingest path is, first of all, it's able to handle millions of writes per second. It's super good for IoT data or with such data which has need for millions of transactions. The second thing is there's this unheard feature called change feed. So change feed is sort of a change log. So every time you insert or update documents in Cosmos DB, it will be written to a change log, and you can process this change log. So it's sort of like a pub sub mechanism, and it integrates, you can use the Spark connector and stream all of this data into Databricks. That's how you get it into Databricks, and then you can do your other stuff. So that could be a potential option. And the other thing to consider is the time to live. So Event Hubs has only a time to live for 7 days, whereas if you wanted these transactions to be more than 7 days, Cosmos DB can do that. You can use it as you can have time to live up to whenever. So let's say if the Woodgrove Bank had a requirement to have these transactions for say a couple of months till they train their other stuff, you can set the time to live property in Cosmos DB, and then they expire the data later. But other than that, Event Hubs is also a great choice. So a kind of like I said, the factors to consider here are rate of flow, data source and compatibility, level of effort to implement. So would you want to use the same service for multiple components using other than using 5 other services? That's something you might want to consider. And then the long-term storage needs. Like I said, the time to live is an important factor. I do see a lot of people taking pictures. The whole solution and the deck is online, so I will give you the link right after I'm done. So I kind of summarized it, but just to sort of give you the idea, Cosmos DB is known for its optimized for high write throughput, provides streaming through change feed, and then you can take use of the time to live feature so that you can automatically expire these documents to save storage costs. So Event Hubs, again, it's like you guys know, it's a data streaming, can persist. So for the batch processing of it, you can use Event Hub capture also. So both guarantee event ordering. So that's another thing you want to think about. If you need to process the events in the order they come in, both of them do guarantee ordering per partition. And it's important how you partition your data with the service. So we did not go into that today, but again, partitioning plays a very important role, and that's something else you want to think about. So for Woodgrove Bank, Cosmos DB could be a better solution just because of the way, because they're already writing payments and they're already using it as a database in the other pieces. The multi-master, so yeah.
Just a quick question.
Yep.
Is there, if we pick Cosmos DB as a source of the instead of
Yep.
Sorry. People on the recording are going to be unhappy if they can't hear the question.
sorry. If we pick Cosmos DB instead of Kafka or Event Hub or as a streaming land, let's call it this way, do we have any limitation on number of streams reading from Databricks? Because if you go through Event Hub, you have for each stream of Spark, you have a consumer group. You have to have a single consumer group. So you in Event Hub limits to 20 consumer groups. So the basic. So is there any limitation on Cosmos on this?
So the question was, are there any limit on the number of consumers, consumer groups? So I know you can have multiple consumers read off the change feed, but I'm not very sure if there's a cap on this, but I can get back to you. Just email me and I'll follow up with you on that. So yeah, and then I don't know, have any, like Cosmos DB is the biggest factor is its multi-master capability. So it's good for global distribution. You can globally replicate your data, super simple. But multi-master is a very interesting feature. So let's say you have your data in North Europe and West Europe, and then North Europe goes down. What are your RTO and RPO? With multi-master, it's pretty much 100%. There's no concept of failover. If North Europe goes down, automatically all your writes will be automatically sent to the West Europe. So for something very important like a payment transaction processing system where you need a really high availability and where you cannot afford any downtime, a multi-master capability could also work in their favor and hence could be a potential good fit for the ingest piece. And the other one, like I said, it's a little bit more difficult to host event hubs in the different geographies versus just setting up Cosmos DB. Maybe this is coming from a biased opinion, but I think we proposed Cosmos DB as a persistent event store, but like Event Hubs and Kafka or the other solutions could equally work well as well. Yep, questions, great.
from my experience, it
Yeah.
will be extremely hard to control cost if there are peaks. So if the ingestion comes in regularly, then it's not a problem to calculate the cost of Cosmos
Yep.
DB. But if there are peaks which I need to handle,
Yep.
then it can be extremely costly. So this is why we gave up on Cosmos DB for a case that is similar.
Yep. Okay, great. The question was cost management. It's kind of hard to predict the costs for peaky workloads in Cosmos DB, which is true. So if you do know, sort of for especially bursty workloads, like say transactions where you cannot predict when the transactions will come in, maintaining that high number of RUs could be a cost factor. So that's where I would say Event Hubs might have a bit of preference because it does autoscale. So that being said, we do have autoscale coming soon. So when I say soon, in November at Ignite, we do plan to have autoscale. So that might solve your problem. For now. Any other questions? You had a question?
It was
It was the
answered,
same
thank
question.
you.
Okay, awesome. But yes, in terms of if cost is a factor, again, it's always a trade-off. Do you need that global distribution and do you need that high availability? And do you want to spin up these different instances in all those different regions? It's sort of that balance between what your business needs. For the data pipeline processing, we chose to go with Databricks. Like you know, Databricks is a managed Spark environment. It's awesome. It can do both data streaming and batch streaming. And it also comes with notebooks, which was a customer requirement that they have. So features it provides, which makes it a good choice, is especially Azure Active Directory integration. Since you have like multiple data scientists and data engineers who need to access this data, AAD and RBAC controls become a key requirement. You can do collaborative features. You can run scheduled jobs. It integrates with Azure Key Vault, and then you can train and evaluate machine learning models. So Databricks will be the chosen solution for actually processing this data. Yes. You had a question? Yep.
I'm just wondering, I agree that for now Databricks is a good idea, but your Cosmos DB PM?
Yes, I am.
Will your, or Databricks, I was
Yes.
wondering.
No, I am
will-
a Cosmos DB
will your
PM. Yeah.
will you still do the same suggestion after the Spark integration in the Cosmos DB?
So no. So the question was, will you do the same suggestion after the Spark integration in Cosmos DB? So basically, there are two different tangents. It's not one or the either. It depends on what your use case is. So if you have
No, it's just because you say the whole solution here is built on the central Cosmos DB as the store end to end. So you do everything of your processing inside that one store. The Spark API integrated in Cosmos DB might then be much more cheaper than having
could
to
be.
set up Databricks clusters and stuff like that.
that could be, but we're talking about an upcoming capability, so we don't know yet.
But it's a preview,
But yes,
Yeah.
we can discuss that more
Yeah.
offline. Yeah, great. So so some things with Databricks. Databricks can connect with both Event Hubs and Cosmos DB. It has connectors for both, and you can do Spark structured streaming to do the real-time part of it, and then you can also schedule batch jobs for offline processing. So some things to keep in mind: you do want to make sure you do a checkpoint directory on your streams, so that should be able to help you restart the stream processing if any job is stopped at any point. And another thing also, you want to use Azure Key Vaults, never copy paste your passwords. That's a big no-no. So Databricks does integrate with Azure Key Vault, so that's where you want to put your Cosmos DB key or Event Hub keys or whatever. Okay, cool. What else? So we do know that it, apart from batch and stream processing, it also is great for ACID transactions. So we will be using Delta tables in Databricks to do to have Power BI and other stuff sort of talk to it, because it also supports automatic file management. You have data skipping and so forth. So before we did look at key management, but anybody else who has any questions on Databricks or who came up with something other than Databricks, I'd love to hear. Okay, we're all on the same page on that one. That's great. So for model training, again, Databricks does support Azure ML. So we thought that could be a good solution. Since we're using Databricks, we can leverage machine learning to train our model and use using our historical payment transaction data. So for the model deployment service and real-time scoring, so now that you have a trained model, where did you guys deploy it? Anybody? Machine learning services. Okay, Azure ML. Okay, great. Azure Web App. Anybody? Okay, cool. In this solution, we suggested Kubernetes because it's highly scalable and highly available. We suggested deploying that solution on Azure Kubernetes service. But web apps or ML could also be good solutions. And so you can use Azure ML. We do use Azure ML as well. So we register the trained model and then you deploy it to AKS so that all the web transactions or the mobile transactions can go to it in a highly available manner. Any questions on AKS? Yes.
So in scenarios where you have to deploy multiple models, for example, we are working on a project. We have to deploy for predictive maintenance. We have to deploy 1,000 model, and in case we use the AKS, if we receive a request, is AKS able to know which instance contains the model that it should use to make the prediction?
That's a great question. I would assume so, but I have to cross-check because I'm familiar with AKS, but I don't really know how the requests or specifics are sort of routed. If anybody else in the room.
Just for the record, what we did, we used API Gateway.
Yep.
We received the request.
I think it should. I think it should know where to route it. Yeah.
Okay.
Yeah, we've done something similar in the past, but we used AKS to spin up models, but they were just, it was like the data came out of the stream, it went to a queue, and then AKS spins up a container that does the processing, and then the output goes out, and then it throws it away. So it doesn't need to know long term. It's more like you send the command to AKS, it spins up a container that runs your model, and the outcome is then ingested back somewhere. And then the container goes away, and the next time is another container that spin up stuff like that.
We're working on a real-time use case. Yeah. We have limits that the models must maintain in memory. We don't want to each time reinstall the instance and reload the model.
Yeah, but I think you can in AKS then do some kind of pooling, that it preheats, let's say, the containers. And stuff like that. Yeah.
Great questions, but unfortunately we're almost out of time. So give me 2 minutes and I will show you what the other pieces are so you get the whole solution and then we can go for the night. So to serve the pre-score transactions, Cosmos DB could be a great choice because of its low latency and its global distribution. Since your merchant customers are all over the world, storing these pre-score transactions in Cosmos DB makes it highly available and the latency will be less than 10 milliseconds, which is what the customer wants. And for long-term storage, we've chose to go with data lake storage, where you'll be storing your data, and then you will be training your model on this. And for analytical servings, you have a couple of options. So you can have the Power BI hook into the Delta Lakes, into the Delta tables, and you can also use Azure analysis services. So this was one question I got from the group. But if you have if you put it in the Delta tables, you have to have a Databricks cluster always running. That could get expensive. So you could also use in tandem and Azure analysis services, and both of them hook into Power BI. So this could be a combination of both. So this is what the final solution looks like. Like you saw, most of the groups came up with very different stuff, which is great. So So there is no one right solution. This is one of the possible solutions. So thank you so much for everyone for coming here today and being so engaged. And I've heard some great ideas and great discussions. Also, if you want to Google it, so if you want the solution and if you want to read through most of it, please look up MCW, Real-Time Advanced Analytics with Cosmos DB. I'll repeat it. It's MCW, Real-Time Advanced Analytics with Cosmos DB. The first GitHub link, you have both the trainer guide and the presenter guide. And you also have the hands-on lab. So you can pretty much go and set up all of these services and get this working end-to-end. Great. Thank you, everyone.